Um,
Good evening, Bhavna ma'am. So I think we all are set to start the session today.
yes, ma'am.
Fine. I hope everyone is listening. Only Bhavna ma'am is responding. What about the remaining people? I hope we can start the session.
Ma'am.
Yeah. Good evening, ma'am. Good evening, Abraham ma'am. Okay, fine. So I think you people are there in a meeting online and listening to me, so we can start the session. As we know that we are using or we are understanding how we can apply data analysis using the Jamovi, and today is the day three where I am going to talk about the t-test. Right? Today the agenda is we need to discuss the t-test using the Jamovi. But before proceeding and seeing how we can perform or how we can use Jamovi, I have a simple question from all of you. Can any one of you tell me that when we are going to opt for the t-test?
Ma'am, when the sample size is less than 30
Okay, fine. Okay. Any other criteria?
and data distribution is normal.
Okay. Okay. Fine, Bhavna ma'am. What about the other persons, other people? Yes. Please be interactive. It's an online session. Hello. I hope everyone is there in the meeting. Do not keep it only one-way communication. Friends, is it something like I need to only deliver, you will not interact any with something? It is something like that? Pragya ma'am, we cannot hear you. I think I can only see that you have tried to speak something. Mic I have seen, but I cannot hear you.
Ma'am, when data are independent
Hmm.
and they are normally distributed,
Fine.
and we compare two groups.
We compare two groups. Okay.
When we compare more than two groups, we use ANOVA.
Okay. Fine. Thank you so much, Pragya ma'am, Bhavna ma'am, for interacting. Okay. So first thing, I think you all are very close and very near to the answer. Very good. Firstly, when I say when we talk about the t-test, so the t-test purpose is firstly to find the significant mean difference, right? Whenever we are interested to find significant mean difference, we are looking at the t-test. This is the first thing, right? Second thing is that there are variety of t-tests available in statistics. Mainly, we can divide the categories into the two, which is one sample t-test and the two samples t-test, right? When we say one sample t-test, meaning is what? We are interested to compare the sample mean with the population mean, right? So whenever we are interested to compare sample mean with the population mean, we are using one sample t-test. This is the first thing. Second thing is that when we are having the two samples, so there is a thing that the samples can be independent or dependent, right? When the samples are dependent, we are using dependent sample status, which is also known as paired sample status. And when we talk about independent samples, in that case, we can apply independent sample status, right? I hope I'm clear.
Can you please repeat it?
Okay, from where I need to repeat, ma'am?
Ma'am, where we can apply one sample t-test and two sample t-test.
Fine. First thing, whenever we are looking for the significant mean difference, in that case, we are opting for the t-test. When we talk about the one sample t-test, so when you are interested to compare the population mean and sample mean, means when you want to see whether the sample is representing the population or whether the sample is the part of your population. So you are comparing the sample mean with the population mean. In that case, you are applying one sample t-test, right? Is it fine, Bhavna ma'am?
Yes, ma'am.
Second case is that is the two sample status. There we are having the variety, which is the independent sample status and dependent sample status, right? So when we say independent sample status, in that case, two samples should be independent to each other, right? And when we say dependent sample status, two samples should be depending upon each other. So that way, in both the cases, we want to see the significant mean difference. That means in case of independent sample status, we are comparing the mean of the two samples. Generally, we can say we are comparing the mean of two populations, right? And we are saying whether the two populations mean are having same or not. This is a case of independent sample status, right? For example, a very simple example, if I will say, suppose I'm having the data of the male and female, and I'm having their satisfaction scores, right? So maybe I want to interested to compare whether the satisfaction between male and female is same or not, or there is any significant difference existing in the satisfaction scores of male and female. In such case, what we do, we are comparing the sample, what I can say, male male respondents satisfaction score with the female respondent satisfaction score, right? So that way, these two groups will be the independent groups, because we know this thing, if a person is a part of one population, he or she cannot be the part of other population, right? Or I can say this thing, that male cannot be the part of female group, or female group cannot be the part of male group. That way we can say this thing, we are comparing the two different samples, and we are knowing this thing, that this is known as the what I can say, independent sample status, right? Second criteria is when I talk about the dependent sample status. In case of dependent sample status, what we are looking for the dependency of the sample. And when it is possible, the dependency kind of thing, it is very simple. When I am saying this thing, suppose I am teaching a topic to a particular group of people, right? So before teaching them, I want to know this thing, that what is their satisfaction, what is their knowledge level, how much they are understanding about a topic priorly, right? So that way we are conducting a first test or first kind of assessment, and then we are scoring, or we are what I can say, collecting their scores, right? Then after teaching those group of people, again we are conducting second time a same type of test. So that way we are conducting a test for same people two times. So we can say this type of sample is a dependent samples, because the people who have involved in the previous test, they will be the same. Means this we can say it's a kind of repeated kind of thing we are performing on a same set of people. So this way, this type of test is known as dependent sample status, right? I hope it is clear, right?
Yes, ma'am, it's clear.
Yeah. So this way, this is independent and the dependent sample status. And one sample, I think I already explained, right? So these are the three varieties in the t-test. Again repeating, one sample, and second one is the two samples. In the two samples, again there's a bifurcation. Bifurcation is what? It is independent samples and it is dependent samples, right? I hope till here I am clear.
Yes, ma'am.
Yeah. Now further, when we will proceed, and when we talk about a statistics, because statistics, it is not like a statistics. Usually in all the fields, there are certain assumptions, right? So when we talk about the statistics, or when we are talking about the hypothesis testing, because from today we are understanding the hypothesis testing, right? So whatever test we are selecting for testing our hypothesis, we need to check certain kind of assumptions of those tests, right? So when we talk about the t-test, so the main assumption is what? There are certain assumptions of the t-test. The main assumptions are the normality of the data, right? You need to check this thing whether your data is normally distributed or not. This is the main thing you need to check. But when we talk about the remaining thing, that is, if I talk about this, what I can say, independent sample status. In case of one sample t-test, homogeneity of variances we do not need to check, right? But in case of independent sample status, you need to also check the homogeneity of variance, right? So in that case, we can say there is one more extra assumption in case of the independent samples t-test in comparison to the dependent samples t-test, right? It is clear to everyone?
Yes, ma'am.
Yeah. Further, I talk about the requirement of the variables, right? What kind of variables are required to perform the t-test? Give me a second. Is it okay the way I am interacting with all of you? It is fine, or do I need to take a help of any word file or something?
It's okay, ma'am.
What
Fine.
about the beginning?
It's okay, ma'am. No issue.
Are you people getting me?
Yes, ma'am.
Pakka?
Yes, ma'am. No issues.
I think I cannot hear that. What I can say that the voice we should come.
Yes, ma'am, it's fine.
Uh, okay, but I think I'm not feeling good. I'm feeling like maybe people are not connecting with me or what. Give me a second. I'm sharing my screen, and we'll talk about these things using a word file. Okay. So as I talk about the t-test, right? I said significant mean difference. Whenever you want to test, we are using the t-test. This is the first thing, right? Then I said the variety or types. So in that case, it is one sample and two samples. In that, there is a variety, independent and dependent. Samples will be dependent, right? Here, samples will be independent. Sorry. Fine, right? So I think till now I discussed this. It is clear, I hope, right?
Yes, ma'am.
Now, again, I'm coming to the one sample. We need to see the requirement of variable. In case of one sample, as it is the name only, so it is very clear we need to have only one sample here or one variable here. So one variable is required in case or to perform one sample t-test, and here the variable should be continuous or numeric, right? In case of two samples t-test, especially when I talk about this, that is independent. Here, you need to have two variables. First should be categorical, right? With two groups or categories. Second is continuous. Generally, continuous variable, generally we are taking as a dependent variable, and this we are taking as an independent variable, right? Then, when we talk about dependent samples t-test, the other name is paired sample. Paired samples, right? So here we will be having one variable. Continuous in nature. But measured twice. At different time. Done?
Yes, ma'am.
I hope clear to everyone. This is
Yes, ma'am.
fine. So this way we have seen the t-test, and these are the simple what I can say requirement of the t-test. Apart from that, I said usually for all the kind of statistical tests, there are certain assumptions. In case of t-test, the main assumption is normality. And if I talk about independent sample t-test, there you also need to check the homogeneity of variance. Right? Then, okay, can anyone tell me what do you understand by hypothesis? Anyone?
Hypothesis is the assumption that we conclude about the study before conducting it.
Very good. It's an assumption, or I can kind say this thing, it's a tentative assumption, right? Or concluding statement, right? But it is not tested, you know. Once you are formulating your hypothesis, it is not tested. You can test it, right? By collecting the data, we can test our hypothesis. It's nothing but it's an imagination. It's a kind of assumption which we have formulated using our own experience or our own observation, which we have done through the environment, right? That way we can create or write any statement. But whether the statement is correct or not, you need to check or you need to test that using the data. Fine. Then there are usually, we can say, alternative hypothesis, right? And null, which you are representing by H0 or H0. This is we represent by H1. Then,
Yes, ma'am.
fine. So whenever we are applying any statistical test, which that we are applying on the null hypothesis, right? And when null hypothesis is not supported by the data, it is quite obvious we need to have something. If it is not, we are concluding. So for concluding other thing, we need to have some other statement that we are treating or naming as a alternative hypothesis, right? Symbolically, null hypothesis we are representing by H0 and alternative we are representing by H1. Fine, everyone?
Yes, ma'am.
Now further, I think one-tailed and two-tailed hypotheses are there, right? So I think that we can see when we will go to that Jamovi, right? Apart from this, I think nothing we need to discuss much about the t-test, that we will see using the data and then we will understand about the t-test, right? So this is about the conceptual background of the t-test. If you are having any query regarding what I discussed, you please ask. If not, we will start with the Jamovi now. Yes.
Ma'am, I want to ask a question. It might not be relevant, but this is something that I want to understand. For example, we just generally construct a questionnaire, right? And in a questionnaire, we used 8 to 10 questions where we collect the information on the basis of that. So our problem is which test we need to apply or to analyze which type of information. So how we can just conclude that?
It is totally depending upon your objectives, man, because everything is linked in the research, right? Once we will talk about the title, using the title, I think somewhere we are trying to understand this thing that what type of what type of objectives we are going to create, right? So firstly, you need to talk about your title and you need to find out the keywords, right? Using the keywords, you will done the literature, right? Literature can also help you to understand your variable in a better manner, because many times it happens we are unable to operationalize our variable. We are not having a proper definition of our variables. Using the literature, we can get the definition, and if we are able to define the variable properly, right? So that way we are having a direction that how now we can measure that variable. So if you are in a position to know how you are measuring your variable, further you need to decide upon what type of objectives you are going to achieve through your study, right? The objectives will give you a direction to formulate your hypothesis. And when we talk about hypothesis, generally hypothesis is formulated in the form of three things. Generally, we are looking for the significant difference, or we are interested to find the relationship or association between the variables, or we want to see the impact of one variable on other, or we are interested to find the, or we can say we are interested to forecast the one of the variable of the study. So generally, these are the three type of hypotheses we are formulating in the research, right? So you need to see this thing, which type of hypothesis you are or you have formulated. So if your hypothesis is talking about you want to compare two groups in the way on the basis of the mean, right? So that way you are having only two choices left, that is the t-test and the ANOVA. Then you need to see the variable requirements of the t-test and ANOVA, and that way you will decide upon that this test you are going to choose. Further, if you are having the hypotheses which are interested or which are directing you to measure the relationship between the variables, right?
Right.
So in that case, you need to be very much what I can say clear, and you need to see the type of variables you are having. If your variables are a nominal scale variable, usually, so you will go for the that is Kendall Stout t-test. Kendall Stout test is available, which is generally helping you to find the association between the two nominal scale variables. If your variables are ordinal in nature and you want to find a relationship between them, so in that case, you can go for the Spearman's rank correlation, right? Further, if you're having continuous variable or numeric variable, you will go for the Kalperson's coefficient of correlation. So that way you are doing the relationship testing using these kind of tests. Apart from that, there is also chi-square test available, which can help you to find the association between the two nominal scale variables. Fine. After that, when I was talking about the forecasting thing, when you want to predict one variable using other variable or other variables, so we are left with the choice of regression test, right? In that case, you are applying the regression test, and using that regression test, you will check which or what is the capability of your independent variables to predict the dependent variable. So I think the basic thing to understand about which test you need to use is very simple. Firstly, you need to be very clear. You need to very clearly state your objectives of the study. If you are able to do so, you need to further formulate your hypothesis on the basis of your objectives. Because if your hypothesis achieved, or means whatever test you have applied and your hypothesis achieved, that means you are able to what I can say achieve your objectives also. Ultimate aim of a study is only that whatever objectives you are stating, they should be those should be achieved, right? So that way it is very means research is not that much tough. Only you need to be very much clear about the things, need to know about the processes. If you are very much clear about your variables and all, and you have clearly defined your objectives, I don't think so it is much difficult to decide upon the test. So test we are deciding later on. Firstly, you need to decide your objectives and you need to formulate your hypothesis, and these should be supported by literature.
Got it, ma'am.
Fine.
Thank you.
Thank you. So shall we proceed now?
Yes, ma'am.
Yes, please.
Okay, so I think I'm expecting everyone to open the Jamovi interface. I hope you have opened it. Once you have opened it, please give me a yes or not, because now I am on a Jamovi interface. So I cannot see the Google Meet screen. So I cannot see your expressions now. In Google Meet, I think you people are knowing this thing. Once you are sharing a screen, you cannot see anything, whatever is going in the background screen. So you need to tell me whether you are ready with the Jamovi or not.
Yeah,
Yes,
ma'am.
I'm
We are ready.
ready.
Fine. Thank you. So as the agenda of the day is, we are going talking about the t-test. Now we will use t-test in the Jamovi. So I think I have not shared any of these sheet with all of you, because here the aim is only to understand how Jamovi works, right? So we will use the data sets of Jamovi only, right? So you need to go to these three lines here, click on this, go to the open, and you need to use the same data library which I have told you a day before yesterday, LSJ data. Done?
Done, ma'am.
From here, I am using a file named as Zeppo, right?
Yes, ma'am. Got it.
So click on this. Once you will click on this, a file will be open for you. Done?
Yes, ma'am.
You can find we are having only two column or two fields or two variables listed here. here. First one is the ID and second one is the X, right? So go to the variable section and you can find here. If I talk about ID, I clicked on this. So you can find ID is nothing but these are the numbers, means these are the identifiers for the students, right? So 20 students data we are having here. Apart from that, we are having the X. So if you have seen the file description, where I have opened it, it was written there. These are the grades of the students of the Dr. Japo's class. Means whatever means this is a particular person, and his class maybe has conducted any test or quiz or something. So these are the scores scored by the students of his class, right? So this is the result. This is the data we are having. It is fine. I think it is not tough to understand.
Yes, ma'am.
Fine. Further, to apply the t-test, because it's Jamovi and even in Excel and SPSS also there is no problem. You can go to the analysis option or the tab, click on this. There you can find the t-test is listed, right?
Yes,
Click
ma'am.
on this, select one sample t-test. Done.
Done, ma'am.
So once you have done this, you can already see the result is already generated, but values are not there, but only format is there. You need to shift a suitable variable in the dependent variables box, right? Here you can see it is asking you or demanding you about the variable that is X, because ID is the identifier. There is no use of shifting identifier in the dependent variable box. So we are having only single variable available, which is X or grade. So shift this using this arrow key in the dependent variables box. Done.
Yes, ma'am.
So as you have shifted it in a means immediately Jamovi has generated the output also. You can see it is showing us one sample t-test. This is the student t-test. This is the t-test value, right? Calculated value of the t. This is the degrees of freedom, and this is the p-value, right? Now you can see it is giving you the alternative hypothesis. I think it is I think H0 or HA. It's H0.
It is H
A.
A.
It's HA, right?
Yes.
Means it is alternative hypothesis, right? So which is saying mu is not equals to 0. Done. Coming, give me a second. पत्थर में थोड़ी ऐसी बात करूँ हमें ना ट्रेनिंग अच्छा है मैं ना ट्रेनिंग बाद में बात करूँ हाँ now you can see although we haven't done anything till now, but still we need some more things here. So what you need to have here, come to the boxes at the left hand side. Below that there is certain statistics mentioned here. So you can find tests under this. Students is by default selected, means this is the students t test, right? So we need only this here. From the right side you can find additional statistics. So we want to get the mean difference also. So you need to select this checkbox. If you want to get that confidence interval value, you can select this also, right? Go down, then come to the descriptive. If you want to get the descriptive statistics for your data, you can select the descriptive statistics also. If you want to get a plot, you can select this also, right? So now further go down, talk about the hypothesis section. Here you can see it is giving you the test value 0. So those who have already worked with Excel and SPSS for the t-test, they know this thing that when we talk about the one sample t-test, because in one sample t-test, what you need to do, you need to compare the sample mean from the population mean, right? This is the main aim of the t-test. We want to see this thing that whether the sample is belonging to the same population or not. So that way, this test value is nothing but this is your population mean value, right? So you want to compare the mean of your sample from the population mean. By default, Jamovi is taking this population mean as 0. It is clear?
Yes, ma'am.
But I think it is not true. We can't say because it is what we are knowing this thing that there is a teacher called Jepo. He has conducted a test, and these are the scores of the students. So it is not like the faculty has not conducted tests before also. Maybe this is the first batch or something he has conducted for that, or the previous batches also he has conducted the test. So that means he is having some idea about the average score, right? So that way, as it is not mentioned in this particular data, but you need to take certain assumption that what can be the average mean. Looking at the data, I think we can say this thing that the data is ranging from 50. I think 50 is the minimum figure, right? And the maximum is 89, right? So we can say this thing that there should be certain population mean value. So suppose I'm assuming the population mean is 63, right? Is it clear?
Yes, ma'am.
I'll tell you this afterward. First, I have just taken one assumption that the population mean will be around 63. Suppose, right? Coming to the next, talking about the hypothesis section. Here you can see there are three varieties of hypotheses are mentioned, and all the three hypothesis type is or are of the alternative hypothesis, right? So, because null hypothesis will be what? Just a minute, I'll come to this. So here, in case of one sample t test, what we can say that the null hypothesis will be that is x bar, that is population mean, is equals to the sample mean. X bar is the sample mean, mu is the population mean. This is your null hypothesis, right? Alternatively, you are saying that sample mean and population mean are not equal, means there is a significant difference. Not equal meaning there is a significant difference. If there is these two are equal, that means there is no significant difference, right? So this is the first way of formulating your alternative hypothesis. Other way of formulating your alternative hypothesis can be less than, and next one is greater than. Done?
Yes, ma'am.
So here in the Jamovi, if you will look, these all three are nothing but these are the type of your alternative hypothesis. So when we are talking about this is the two-tailed hypothesis, right? This is one-tailed. Getting me?
Yes, ma'am.
Here you're clearly saying mu is greater than or less than. That means this is a case of one tail, but where there is the dilemma, or you are saying that x bar and mu is not equal. That means it can be either greater than or it can be either less than. Both the possibilities are involved in this alternative hypothesis, where this is a case of two-tailed test. Is it clear? I hope, right?
Yes, ma'am.
Fine. So by default, this Jamovi takes your alternative hypothesis is not equal to, means generally even in researches also many a time it happens we are mentioning that there is a significant difference, right? Whether the difference is greater than or less than, initially we are not concluding, but looking at the results you can conclude that also. I hope till here I am clear. May I proceed?
Yes, ma'am, please.
Further, you need to check the assumptions also. So you can click on the normality test and QQ plot. Both are the ways of checking the normality. In this normality test, you can find this is coming for the Shapiro-Wilk test. This is coming, right? And QQ plot is coming downward. This is your QQ plot. That is quantile plot, right? Both are the two ways of checking the normality. Both are indicating you the normality of your variable, which is the grade, right? So looking at this particular graph, which is of the QQ plot, this is nothing but this is the fitted line. And if I look at the fitted line and I look at these data points, so somewhere you can say data points are approximate nearby to the line, but they are not exactly following also, right? If they are exactly following your line, whatever fitted line is there. So that means your data is 100% normally distributed. But there is little bit problem with the normality, but still maybe we can comment that there is what I can say, approximate your grades are normally distributed. If I will look at the QQ plot. Coming up and talking about the normality using the Shapiro-Wilks test. So this is the section where I am getting the normality test Shapiro-Wilks, right? There you can see the p-value is 0.586, right? So this p-value is very high, right? So very high meaning is it is greater than 0.05, because confidence level value is 95%. I haven't changed it to the 99 or 90 something. I'm comparing the p-value from the 5%. I can say 0.586 is greater than 0.005. That means I cannot reject the null hypothesis of Shapiro-Wilks test. And the hypothesis of Shapiro-Wilks test says to us that our data is normally distributed. So if you want to write the hypothesis of Shapiro-Wilks test, you can write hypothesis, null hypothesis of the Shapiro-Wilks test says variable or the data is normally distributed, and according to the p-value we cannot reject the null hypothesis. So we are concluding that our grade or variable, which is the name of variable, our grade variable is normally distributed. And if you will look at the note is also saying the same. A low p-value suggests a violation of the assumption of normality, but our p-value is very high. Is it okay?
Yes, ma'am.
Descriptive statistics, I don't think so I need to comment anything. It is indicating with the mean score of the grade, median value of the grades, standard deviation, and the standard error of mean. Total observations are 20. Coming to up, talking about the test, which is this, which is saying you the t-value is 4.37, degrees of freedom were 19, and the p-value is less than 0.001. Means we are talking about the 5%, but this value is even less than from 0.001. That means you are not holding your null hypothesis and you are going with your alternative hypothesis. And that way you can conclude that there is a significant difference in the mean, sample mean and the population mean, right? Now, if you will talk about what is the mean difference, you can see this thing, the mean difference is coming as 9.3, right? Because your sample mean is what? 72.3, and we have passed here the hypothesis, the new value as 63. So you can take the difference of 63 and 72.3, which will come as 9.3, right? So that way you can comment that your sample mean is higher than your population mean, because population mean was the 63, sample mean is the 72.3. So you can comment this thing that sample mean is greater than population mean, right? Looking at the 95% confidence interval, both the limits, that is lower limit and upper limit, both the limits are positive. That means whatever you are concluding is reliable here, right? So this way, this is the one sample t-test. I hope it is clear.
Yes, ma'am.
Okay, only Bhavna ma'am is saying yes. What about the remaining persons? I hope it is clear, everyone.
Ma'am, I have a question.
Yes, ma'am.
Ma'am, the last thing that you explained about the 95% confidence level, can you explain it again?
Yeah. When we talk about 95% confidence level, always you need to see one thing, that both the limits should be either positive or negative. This is the main requirement of the reliability, right? You can only say this thing once the values are positive or negative. If both, means these limits should not include 0. If both are positive, it is quite obvious 0 will not be involved. If both are negative, it is quite obvious 0 will not be involved. So that way you can say you are 95% confident about whatever you are concluding. So these limits should be either positive or negative. Now I hope it is clear.
Yes, ma'am. Thank you.
Thank you, ma'am. Anything else? Nothing? Shall I proceed with the next test?
Yes, ma'am.
Fine. Now again I'm opening one more sheet here. Go to the again those 3 lines. Open and the library. Now I'm using this Harpo. May I? May I open this? I hope everyone has located this, right?
Yes, ma'am.
Fine. So here you can find, here we are having 3 columns. First one is the ID, second one is the grade, third one is the tutor. So there are 2 different tutors in your data set, and these are the grades achieved by the students according to the tutor. Means suppose this particular student is the student of the Anastasia's tutor. So the particular student has scored 65, right? Second one is Bernadette, the student of the Bernadette Saro, ma'am. I don't know who is he or she. So the student has scored 72 marks, right? So that way, now this is a case of which test? Can anyone tell me?
Two variables are there and we have to compare them.
So this is a case of
Two sample test.
Two sample t-tests.
very correct. Very correct. Thank you, everyone. So we can say this thing here. We are having grade, that is your numeric or continuous variable. We are having the second variable type of tutor, or the I think we can say type of tutor, tutor A and tutor B. That is Anastasia and the Bernadette, right? So we are having the categorical variable type of tutor. In that we are having 2 categories or 2 groups, first person and the second person. So we want to compare the students' score, those who have studied or those who have got the what I can say classes from the Anastasia sir or ma'am, and or from the Bernadette sir or ma'am. Get it? So that way, this is the perfect, or what I can say, according to the independent sample status, the data or the information is very up to the mark, and on this particular data we can perform the independent sample status. Is it fine? May I start explaining now?
Yes, ma'am.
Fine.
Yes.
Again, we are going to the analysis using the t-test. We are selecting the independent sample status. Then
Yes, ma'am.
shift the grade in the dependent variables box and tutor in the grouping variable box. Then
Yes, ma'am.
I am selecting the mean difference, selecting the descriptives plots. We'll go with the alternative hypothesis we are taking. Not equal to means there is a significant difference type of hypothesis I'm taking. I'm using all the assumptions to check the assumptions of the independent sample status, which is homogeneity of variance, normality test, and again normality test using the QQ plot. Missing value cases, if your data is having any missing values, so it will be included, means it will be excluded. Case analysis by analysis means per case, every case will be checked. If there is any missing value, that case will be dropped by the software, right? Done?
Yes, ma'am.
Okay. So coming and talking firstly about the assumption of the independent sample status, which is what? Which is saying you the p-value is again very high, which is 0.827. So according to the hypothesis of Shapiro-Wilk test, which we can conclude this thing, because p-value is very high. So we are holding the null hypothesis, and we are concluding that the grade variable again is normally distributed in case of this particular data. Is it okay?
Yes, ma'am.
Looking at the plot, although all the data points are not exactly on the fitted line, but somehow they are following the line, means there is not much deviation in the line and the data points. So that way we can say the data is approximately normally distributed. Coming to the group statistics, you can find the students who have studied or who have got training from Anastasia sir in number are 15, and from Bernadette who have got the training, they are in number 15, right? These are the mean scores of the students, and the median and standard deviation values are mentioned here, along with the standard error of mean. Coming to the next, talking about the, I think homogeneity of variances I not explained, no?
Yes, ma'am.
Now the next assumption is about the homogeneity of variances in case of t-test, which is generally checked by the Leven's test, right? So thus, this is represented by the F statistic. The value of F is 2.49 for the degrees of freedom 1 and 31. The p-value is 1.125, which is again greater than 0.05. So what you can conclude? You can conclude that there is a equality of homogeneity, meaning is what? Equal variance. Means the grade should have equal variance in both the categories. In both the categories means in both the groups. Group of Anastasia and the group of Bernadette, right? So we can conclude this thing that the variance is equal, or there is an equal variance in the grade, right? So this is, we can say that both the assumptions are what I can say, checked and kept by your data or followed by your data. Is it fine? May I proceed?
Where variance is equal, as you said.
Means?
As you mentioned, that variance should be equal to.
This is the assumption of the t-test, independent samples t-test. Homogeneity means equal variance, right?
Okay.
So according the hypothesis of the Leven's test says variance is equal. This is the hypothesis of Leven's test, right? Looking at the p-value is very high, which is greater than 0.05, right? So you cannot reject your null hypothesis in this case. So according to your hypothesis, you're concluding that the variance is equal between both the groups for the grade. Means your grade is having the same variance in the first group, that is Anastasia, and then second group also, which is Bernadette. This is the conclusion. Hello.
Ma'am, but here p-value is less than 0.05, na? Or 0.5. Or 0.05. We need to take it from 0.05.
5% means 0.05. It is not 50%.
Oh, got it. Sorry.
Fine. Coming up, talking about, I think normality we checked, variance we checked, this group statistics we talked about, and the QQ plot we have talked about. Coming to the main table of the t-test, which says student t-test statistic, the t-value is coming as 2.12, degrees of freedom are 31, p-value is 0.043. So, Bhavna ma'am, now you tell me if this is the p-value, what will be the conclusion?
It is less than that, so we will. The data is normally distributed that way.
We are talking about the t-test.
Sorry, variance. Yeah. Sorry.
No. Ma'am, keep calm, keep calm, keep calm. Try to understand thing is what we need to check the assumptions first, right? Because these are the softwares in a one go, they are giving everything to us. Fine. So I came last on this t-test table, right?
Okay, we are just comparing the both the samples, whether they are
having the same mean or not.
Same mean or not, whether they're independent or not. So it is less than 0.05. That shows both the samples are independent to each other.
Okay.
They are not related. They are not related, or we can say.
Okay. In terms of mean, you need to comment, ma'am.
In terms of mean difference. The mean score is 5.4. Okay, that means the mean, population mean of one group is not related. Not, I am not getting it, I guess.
Anyone else?
That means the
ma'am, this means
this is not different, very different from each other.
Okay.
There is no significant difference. Okay.
I think there is no significant difference between both of the two teachers, because if we are talking about mean 74 and 69, it's hardly a difference of 5. That means the students are getting well from both of the teachers.
Okay, fine.
Ma'am, the p-value is less than 0.05. That means the null hypothesis is accepted.
We can say both the teachers are teaching in the same way.
Give me a second. I'm completing this and then we'll talk. I have written there is no significant difference, or there is no significant difference in the mean grade of the students studied from tutor A and tutor B, right? Alternatively, I'm saying there is a significant difference in the mean grades of students studied from tutor A and B. I think hypothesis is clear. No problem with the hypothesis.
Yes, ma'am.
Right. Now we are talking about the p-value. P-value is 0.043, right? Which is less than 0.05. I think it is fine, which is 5%, right?
Yes, ma'am.
Now, if this is the case, thumb rule, what thumb rule says, if your p is less than level of significance, which we have kept as 5%, right? So in such case, what you need to do, you need to reject H0 or H0 and vice versa, accept H0, right? And vice versa meaning is very clear that P is greater than level of significance, right? This
Okay,
is,
ma'am.
I hope it's clear.
Yes, ma'am.
No problem, it happens. I think this is what even I have got take so much time in understanding, or what I can say, mugging up these concepts. But now these are on tips because we are teaching now. So now we can easily say this thing. No problem, it happens. Thing is very simple. You need to be very much clear what the p-value rule says. P-value rule is very simple. Based on, you need to always compare your p-value with the level of significance which you have set. It can be 5%, 1%, 10%, any percent it can be, right? But mostly used are 1, 5, and 10%. In social sciences, we are generally using 5%. So I generally compare my hypothesis by 5%, but it is not mandate for you. According to your field, you can select your percent, right? So whatever is your percent, that from that percent, you will compare your p-value. So if I am comparing, it is quite obvious. Our p-value is less than our level of significance. And the rule says if this is a case, so you need to reject your null hypothesis. So we are not going with the null hypothesis, and we are concluding that there is a significant difference in mean grades of a student studied from A and B. Means might be possible there is a certain what I can say pedagogy, or maybe more discussion held by any of the tutors which can help the students and able to make them score better, right? So if I want to comment on that, I'll come back to the sheet. And I think I have not used this 95%. Yes, I'm using this, right? Now you can see if I talk about the mean difference. Mean difference is coming as 5.48. And if I'll come to the group statistic, I can easily say this thing, that the students who have studied from anesthesia, they have scored around 74.5 grade. This is the mean grade, right? And Bernadette students have scored around 69.1 as a mean score. If I'll compare these two, it is quite obvious students who have studied, or the this anesthesia has taught to the students, those students have scored better, right? So there is a main difference existing, and our data and our test is also suggesting we are going with the alternative hypothesis, which is saying there is a significant difference. Fine. And if I will look at whether I have concluded in a good manner or not, looking at the 95% confidence interval, I can see my lower and upper limit both are positive, means they are not including any zero. So it is quite obvious. I can say that it is a reliable conclusive, right? At 95% confidence level. It is clear.
Yes, ma'am.
Any doubt?
Yes, ma'am. No, ma'am.
No issues. Don't be feel like shy or something. No problem. It is a learning stage for every one of us. Only thing is that you please make your note properly, so that if you are using these things in a future, or maybe in a later date, and within 2-3 days, if you are using the same thing, you would able to conclude the things properly, right? That is a mandate and the important thing of these FDCs. So shall we proceed now?
Yes, ma'am.
Fine. I need to check now. I am not knowing because two I have already checked that in two data sets we were having or we got the correct the results or the correct t value. I need to check. Okay. I'll open this and I'll check whether we are having the paired t-test data available with us. Yes, we are having. You need to open this CHICO, CHICO data set.
Yes, ma'am.
Bhavna ma'am, what happened? Why you are sounding low?
No, ma'am. Today I'm tired. That's why.
Okay, fine, no issues. So now we will talk about the paired sample t-test, and you need to see the use case or you need to understand the application. As I said, the sample should be dependent. So here you can see the tutor name is Chico. He has conducted the first test of the student, and these are the grades. So the 20 students, those who have appeared in the first test, the same students were repeated for the test 2 also. So these are the scores scored by the students in the first test and then the second test. Fine.
Yes, ma'am.
So that way we can say this is a dependent sample because same number of people have been interrogated or evaluated twice. So this is a dependent case and we are having a one variable available which is the grade, which is dependent in which is numeric in nature. Fine.
Yes, ma'am.
Okay. I think I am applying this very first time using this, but I think the right way I will tell you. I need to check how to do that. I'll go to the data. Then
Yes, ma'am.
I want to transform. No. Okay, I'll go with the transform. Done. I'm giving the name as difference. But I think just a minute. Yeah. Go to the difference. Sorry, write the name of the variable as difference. But there is a problem. Wait. We will not do this. Wait. We need to compute a new variable. Whether it is allowing us to compute, yes. Computed variable is just a minute. I went on this computed variable, but it is, I want to perform a calculation just a minute. I need to see how I can do that. Double clicking on this. Yeah, done. You go to this add and click on the append. Done. And
Done.
then double click on this particular computed variable window will open for you. Here I'm giving the name as difference, right? Grade underscore test 1 minus grade underscore test 2. So same name you need to type, which you can see in your columns, right? Then
Yes, ma'am.
and then press enter. You would be able to see the differences coming. If it is done, everyone has performed this. I hope, may I proceed?
Yes, please.
Go to the analysis, t-test and use paired samples t-test. Done?
Yes, ma'am.
But I think it is not working in this manner. Give me a second. Okay. Means this is the thing when we talk about the Jamovi. Jamovi itself calculate the difference. You do not need to calculate the difference by your own. You need to only shift your variable to the paired variables box. That's all. Done?
Yes, ma'am.
After that, mean difference I selected, confidence interval also I selected, Hypothesis, we will go with the by default. Descriptives, we need to have. So I'm selecting this, and then we need to check only the normality. So I have selected both the check boxes. Till here, I'm clear to everyone.
Yes, ma'am.
Done. If all the selections are done, you can come and firstly check your assumption, which is the normality given by the Shapiro-Wilks. The p-value is 0.678. So now, can anyone help me to conclude the results of Shapiro?
It is more than 0.678. So we will reject the null hypothesis, I guess.
Okay. Okay, Bhavna ma'am said this, fine. Anyone else? Any corrections or it is correct? No corrections? Friends, we just discussed this, Shapiro-Wilks. Okay, anyone can tell me what is the hypothesis of Shapiro-Wilk?
Yes.
Hypothesis of Shapiro-Wilk is that your variable is normally distributed. And looking at the p-value is greater than your level of significance. This is 0.678, means almost 67 or 68% almost. And p-value is only 5%. Oh, sorry, the alpha value is only 5%, right? So p-value is greater than your level of significance, that is 0.05. So you cannot reject the null hypothesis, and that way you can conclude that the grades or the grade variable is normally distributed. Is it clear?
Yes, ma'am.
Fine. Going down, looking at the QQ plot, which is indicating that some of the data points are little deviating from the fitted line. That way we can say this thing, that there is some problem with the normality. But when we are talking about this Shapiro-Wilks test is letting us know, or it is assuring us that your variable is normally distributed. So it is up to us which particular way we are accepting or we are using to, what I can say, to confirm about the normality of your data. So either you can go with the Shapiro-Wilks or either you can use your QQ plot. Not necessary to use both. Then next, coming to the results of paired sample status, there you can find the t-value is -6.48. The degrees of freedom is 19. P-value is less than 0.001. That means we can say we are not accepting the null hypothesis of the paired sample status, and we can reject it, right? If we are rejecting the null hypothesis of paired t-test, I think we haven't formulated. So what will be the hypothesis here? Paired t-test. Anyone?
There is significant difference between the two samples, or we can say there is significant between the grades of the students. I'm sorry if I'm wrong.
No problem.
There is significant difference between the mean score of these students.
Right? Done?
Yes, ma'am.
So we are not accepting the null hypothesis because p-value is very small. It is less than 0.001. So we can conclude that there is a significant difference between the mean grades of students before and after teaching. Right? That means we can say whether the teaching is good or whether teaching has improved the score. So we can see the mean difference, which is negative, because it is grade test 1 minus grade test 2. So it is negative mean difference. means grade test 2 scores is more. Or if it is still you are not clear, you can look at the mean value of this, and that way you can find the grade test 1 is 57 and grade test 2 is 58.4, right? So that way what you can conclude that there is a significant difference and it is improved, or grade 2 test average has improved. That means the teaching was effective, right? Because mean has increased.
Yes, ma'am.
Right. Looking at the confidence interval at 95%, we can say upper and lower both the limits are negative. That means your results are reliable, or your 95% confidence to declare this thing that there is a significant difference in the mean grades of the students before and after teaching, or you can say this thing that teaching is effective, right?
Yes, ma'am.
I hope clear to everyone.
Ma'am, I guess when you ask for P value, na, so I just got confused between whether I need to tell for t-test or Sharper Wilks. So that mistake I generally do.
Okay, but I think, ma'am, do one thing. You please make your notes. Means once and twice, if you will try to use those notes, no. So that will be your that will become in your habit, and it will be easier for you to then conclude.
Yes, ma'am.
Simple, you need to keep one thing only in mind. If P is less than your level of significance, in that case, you are not accepting the null hypothesis. That's all. And vice versa will always, you can then make by your own. If P is less than level of significance, you are rejecting null. Vice versa, if P is greater than level of significance. That's all. Right? So you need to be very much clear. If you have able to mug up the first rule, second rule by yourself you can make.
Yes, ma'am.
Right. So friends, I think this is all from my side. Now the platform is open for questions and answers if you are having any. May I stop sharing my screen?
Yes, ma'am.
Fine. So, okay, now platform is open for questions and answers if you are having any.
Ma'am, can you repeat the analysis for Shapiro-Wilks test?
Variable is normally distributed.
And that is the null hypothesis. Okay, ma'am. Thank you.
And Deepshika ma'am, I think the good thing about the Jamovi is that if you will look at the Shapiro-Wilks test, right? So bottom to the normality, I'll show you again. Give me a second. It is itself is writing. So I don't think so. If you're using Jamovi, you need to mug up all these things. Okay. But we should know this thing. You can see here, ma'am. It is written, a low p-value suggests violation of the assumption of normality, right? If p-value is low, right? But our p-value is very high. High meaning is what? From your level of significance, it should be greater than. So which is, that means your test or your data is not violating the normality result. That's all. It is already written there. So this is a good thing about the Jamovi.
Yes, ma'am.
Right?
Yes, ma'am. Yes, ma'am.
Fine. Fine. Okay. Anything else? Okay. No other query?
No, ma'am. Thank you.
Fine. So I think we are meeting tomorrow, and tomorrow is a day of, I think, ANOVA. Fine. So we'll discuss ANOVA tomorrow. Till then, you please try to practice the things. Already data sets are available there. You can use those data sets. You can even repeat on the same data set also. So how you will proceed, I give you one hint. Whenever you're applying your test by your own, always try to formulate your hypothesis first, right? Decide your level of significance and then apply the test and then compare from your level of significance and then conclude your results. That's all, right?
Yes, ma'am.
Fine. So thank you everyone. If no more queries we are having, we can wind up the session for the day.
Thank you, ma'am.
Thank you so much, sir.
Thank you, ma'am.
Thank you everyone. Yogaraj sir? Sir, we are done for the day. Thank you. Thank you, everyone. We are meeting tomorrow now. Good night. Take care, everyone.
Thank you, ma'am. Thank you.